Hi, I'm Karthik, and I'm here to talk about the multiplayer, exciting multiplayer, state of multiplayer thing. So, in recent years, multiplayer has been evolving, and more games are going mainstream, and they are becoming multiplayer network games. So there's a maze, and there's a lot of decisions and confusion regarding what to choose and how to go forward. So I'm going to cover that thing. Um, um, we'll divide this talk into three parts. One, I'll tell you, I'll skim through what multiplayer is and what you have to look at it when you are looking at multiplayer things, right? The concepts thing. Then we'll go into existing solutions or libraries, frameworks, those things. And the third part we'll open for Q&A. Okay. Yeah, I think you can't see it, but yeah, this is the platform which I have been building at Indus Game Studio. I work there along with our team, and this is a game server and game backend thing. This is what we do daily, and I'll go back to talk. Okay. So what can you expect from this talk? This is a tech talk. If you are looking at some like business kind of thing, this won't be that. And we'll go through concepts. And there are various networking models which you have to look at it. I'll go skim through that. And then what are the various options available if you want to build a multiplayer game, right? So there are like multiple libraries and all those things. We'll navigate through that decisions. And this talk is not about won't be helping you making business decisions like pricing or what is the best multiplayer solution out there, or there won't be any recommendation saying that okay, you can use this, you won't be using this, or you should not be using that kind of recommendations won't come out of this talk. This is more, look at it more as a technical talk, right? So whenever we say multiplayer, right? So there needs to be some elements which make up that multiplayer thing, right? So there are like 6 things you can always see in any kind of multiplayer, right? One is input. Second is you have to sync the state. Okay, so inputs are like player inputs kind of thing, those things. You have to sync states between different devices, clients, and different locations, right? So then there is always a transport. Transport is the network transport which you are talking about. There is always a latency. Okay, so you have to factor in that latency whenever you are developing multiplayer. So and then there is always failures because it's not a single device we are talking about. There is some failures can be recovered, some cannot be recovered, right? We'll navigate through them. And then there is a concept called authority. Okay, so because there is a distributed thing which runs over multiple devices and multiple environments, right? So who owns an object, right? Who owns a game object, or who owns this data? Who can set it? Who can invalidate some data? Who can reject some of the inputs? All these things will always be there in any multiplayer. These 6 elements will be there. If you are looking at developing any multiplayer, these 6 elements will always be there. Okay, so we'll go through each of it. We'll skim through. So we'll talk about the input. So inputs, player actions in the game are inputs, right? His mouse clicks, his key press, button clicks, everything is an input. Along with this, for a multiplayer game, a time might be an input, right? There's a time ticking which will be there for a timeout, or like say a turn timer or a game timer, like game has to end in 5 minutes or something like that. So that might be input. We'll come back to this why I'm saying time is an input later, but you have to understand that for a multiplayer game, the input, when we say input, we are talking about player actions and these things. Okay, so this will change the state of the game, right? So when I say it's state of the game, so what is the state of the game, right? So currently I'm playing a shooter game. So there are four enemies are there, and one of them has 10 health. Okay, so all this thing is state. So this needs to be synced over multiple devices, right? State means the data in the game at this current point of time. Okay, that needs to be synced. Now when we say we have to sync the state, it doesn't mean we have to send the whole copy over the network. There are different algorithms, different ways how you sync the state over network, right? So diffs can be sent and all those things. But now when I say state, you have to imagine, it might be a little technical, but you can imagine game as a state machine. Okay, so the inputs and these things will change the state machine. So it will go into a different state, right? So that state needs to be synced. But yeah, it will become a very technical thing, so I'll leave it there. So we have input, we have state. The state will modify over time, right? And based on the inputs, but it has to be sent over different devices, right? So on the network, you have to send that. That is the transport. Okay. So transport, you have TCP and UDP, two primary transports. These are the standards which we have. So TCP is ordered and reliable. So if there is a packet which is lost, TCP will always resend it. There will be a ACK, ACK, and all those things will be there, technical things. So TCP is ordered and reliable. UDP is unordered and unreliable. Okay, these is according to the spec. So unordered in the sense like a packet which is sent now won't reach the destination exactly in the same order which is sent. The packet which is sent after the first packet might reach earlier, and packet which was sent first might not even reach any time. Okay, or it might reach after second packet has received. So this is the reason why they say it's unordered, and it's unreliable because first packet might be lost, and client doesn't know, server doesn't know. Okay, so these two things are TCP and UDP. Why they are really important is if your game has a lot of data which needs to be synced, they generally use UDP. Okay, so that is because UDP is fast. UDP, the speed from the UDP comes because speed of the UDP comes because they won't be waiting. The server won't be waiting for acknowledging the receipt. So client doesn't, generally it happens very fast. Most people won't even realize. But every packet which is sent in a TCP will be acknowledged by the client, right? So those things won't be there, so it will be fast. Okay, you can send a lot of data. Even if one packet is not received, it will just wait and it will skip and it will take the next packet. So that way, right? So that's the reason UDP is fast. So can anyone guess what WebSocket is? TCP or UDP? Any answers or anything? WebSocket? TCP, right? Who said it? Yeah. Abhishek. So we have some goodies we will be giving away. So WebSocket is TCP. Quick. Anyone have heard about Quick or something? So Quick is a new protocol which is coming up. They have used in Google Chrome first. Google used this. So this is over UDP. Okay. So anyone knows about what socket is? Either TCP or UDP. Exactly. So socket is a generic thing. It's a trick question. So socket can be a UDP socket or a TCP socket. Socket is a socket. Okay. So WebSocket browsers support WebSocket. Quick browsers. They are saying that this is going to be successor for TCP sometimes, but it's not going, like there is no way to know. It's only that time will tell what is going to succeed TCP or whatever it is. Okay, so the industry moves ahead and people adopt and browsers adopt, tooling adopts. So it will be deciding. So we should most of the games, if you take any multiplayer game, right, 90% of the multiplayer games or 80% of the multiplayer games, they use TCP. Okay, UDP is used very less. UDP is used whenever there is like you have so much data to sync, right? So failure. So in any multiplayer game, there will be always be failure. Yeah. So randomly give those things. So So any multiplayer game, there will be failure because it's connected to network. Network is unreliable, right? Network is never reliable. It's only reliable in theory, or even in your LAN or anything will be unreliable. So there will be failures. There can be three kinds of failures. One is host failure. Host failure is the server failure, right? Whenever a server might go down, right? Server might crash. Something will happen. So server, whenever there is a host failure, it can be handled. There are many monitoring tools. Those servers can be restarted. The game can be restored. Okay, if the clients wait for that particular time, that error can be recovered. Okay, then there is the network failure. So network failure, if network failure happens, nothing much can be done. Okay, so that's not in the control of anything. The only thing is if they can connect back, can the game be continued? That is a question which is dependent on the game, right? Technically. Then there is the client failure. So there is a crash in our game. It crashed and it is restarted, right? How is going to join it? So these things are not in the hands of the actually multiplayer solution per se. It depends on the client. That guy might close the mobile game and leave, right? So the only host failure can be recovered for sure, but the other things are not in anyone's control. Okay, so restoring game state can be done whenever there is a network failure, client failure, those things. But so what happens if a player disconnects, right, because of the crash and something like that, and he joins back? Can the game be continued? If he has to take a decision, right, he has to it's a turn-based game. He has to bet like poker. He has to bet his turn. So he disconnects during his turn. So what needs to be done? Can he continue that? So those are the questions which are there. So this is up for the game producer or like who are building that game. They have to decide those things, whether what happens in case of failure. So authority. So authority is like there is always data, right? Data needs to be synced. Now, if data is in the clients, okay, in the mobiles or something like that, because in some of the multiplayer games, one of the mobile device is the server. That is called client server model. Okay, Photon and some of those Photon things you use it. So client server model. So if they can manipulate the data somehow, theoretically, I am not talking about Photon or anything. If there is a client server model, it is there, and they can manipulate the data. Can the data be synced to everyone else? So it might be a cheating thing, right? So so this client server versus authoritative server, right? Authoritative server is like server controls everything of the data. Okay, they control the data, and the data whenever there is authority, what is the authority? They can decide on something, right? So they can decide on invalidating inputs, or they can decide on invalidating a game state. So those things are there. So cheating, most of the cheating is because of the authority. Okay, so whenever there is some technical manipulation happening, right? So there can be scope for cheating. So cheating arises because of the authority in the multiplayer. So these not per se topic, but one of it. So because of the authority, this comes up. So most of everyone experiences this thing, right? Someone will say, okay, in Ludo game, that guy is getting sixes and he's killing me or something like that, right? So there are two things. One, it might be really happening, or one, it might be really bad algorithm or random number generation which is happening, right? One of it. So random number generation is a very complicated topic. So dice throws and all those things happen due to random number generation. So that's the reason I say cheating is sometimes imaginary and perceived. Okay. Sometimes the opponent is very skilled. So in shooting games or something like that, right? Even before you raise a gun, that guy might kill you in Fortnite or something like that. That guy is really good, but you might feel like, oh, the guy is a bot. He is killing me. He is using some aim software. So that's the reason I say it's imaginary. It might be imaginary or perceived. So cheating you can classify into two things. One is technical cheating, where you use aim bots and all those things. Then the second kind of cheating is behavioral cheating. So you manipulate the game lobby so that your players join more and try to dominate the game. One of you will always win because you are cooperating and you are winning that, right? In Rummy game, most of the people are your players, or in a Fortnite or shooter game, most of your players are your players. So these things will be there. Anyway, cheating can be detected, and it's a kind of different way, different topic. So it's more the it's a business decision of what to do with cheating, whether you have to ban players, whether you have to stop things, and whether it really involves money or something like that, right? So all these things are there. Sometimes cheating, no one cares because that game is like simple game, right? So so in case you are starting out to build a multiplayer game, okay? So first you have to answer few questions before you start it, right? So you have to have the awareness of what you're trying to build. Otherwise, you will be confused with the solutions which everyone is presenting. In the end, I want to build a multiplayer game. What questions do you have to answer, right? What kind of game are you building? That's the very first question which you have to answer, because if you read everywhere in the internet, someone will say X is really better in building multiplayer games, Y is really better in multiplayer games, and those things will be there. But is that the same game which that guy who wrote that thing has built, or you are building a different game, right? So what is the genre of the game? Is it FPS? Is it like turn-based? What is it, right? So what does the gameplay involve? Does it involve physics? Does it involve movement? Or it's very low physics or low transformations game? So is cheating relevant to you? If cheating is not relevant, you can take a solution where cheating doesn't matter, right? So that's okay. Some guy will leave a random review on the Play Store saying that everyone is cheating or they're bots, but that's okay. So, but it's a real money game, then you might have to consider this, right? So then, how much data? What is the amount of data you have to sync? Some games inherently you have to sync a lot of data for that gameplay to happen, right? For some, it's very less amount of data. Okay, so these how often the data needs to be synced? So is it burst you have to sync the data, or you have to sync continuously stream the data to the other devices? So it might be dull or boring answering these questions, but when you answer these questions, you will realize what kind of game, what kind of solution will help you building that multiplayer game, right? Otherwise, it's like you'll try to take X solution, implement it, but then you realize, it's not for me. It's too complicated. The solution might be really good, but it's not for your use case. Your use case is very simple, so you might be very well using a custom solution or whatever other solution, right? So one thing before we move into the next part, right? Now this ends the technical conceptual overview of multiplayer thing. Okay, so we'll move to the next part. The next part is like game backend, game server kind of thing. So I'll tell you about various options you have, like what are the options in the market, libraries, what are those things, right? So before that, we'll cover one small topic. So there is generally confusion regarding a game server and a game backend. Okay, game backend is where you store data, like your logins, your authentication, your what are the player data which is generated, or the data you want to inject into the gameplay, right? So it might be cards in a CCG game, or it might be anything, right? So that is game backend, achievements, leaderboards, all those things, right? So it's also called BaaS, backend as a service, if it is hosted in a cloud, like Unity offers one, PlayFab is there, GameSparks, earlier we had GameSparks, then there are Beamable, whatnot. Game backend, when we say game backend, that is for storage of the data. With the game, when the game runs, the data is generated, right? Then there is the game server. Game server is more about multiplayer kind of thing, where you sync, which is used for syncing the data across all devices when your game is being played, right? So whenever we say game server, we are talking about the second part. Game backend is a different thing, but you need both. Most of the times, 90% of the time, you need both when you are building a multiplayer. Okay, because his sessions will be there, his themes will be there, something will be there, right? The game generally has it. So these are the options currently In 2022, these are the options you have if you are not building a custom solution. Okay. Your own framework, your own solution, your own deployment, that's a different story. But these are the options which you have. I am sure I have left out many of those things. You might have seen Forge or Fishnet or something like that. But these are most popular. Like they are in production. They have some of those clients which are there. They are using it. So I have listed in alphabetical order. So no particular way. Colossus is not better than Photon. Photon is not better than Unity multiplayer or anything. Whatever works out for you, that is better, right? So Colossus, I think I'm not pronouncing it correct, but yeah, very difficult to pronounce. I searched on the internet how to pronounce it. Even Google could not get it. Yeah, I did not get the meaning of that. I don't know. I have to search for it. So Colossus is a game server. So it's not a game backend. It's only game server. Okay. You can build authoritative games and relay games. So relay, there are two servers, right? Authoritative, relay. So whenever the server can decide what is correct and what is wrong and invalidate something, that is the authoritative server. Okay. Whenever the server just pushes data across every other device, right? So some data changed, they will send a packet to server. Server will just broadcast the same state or whatever data it receives to everything. That's what you see in web conferences, normal conferencing, right? So real-time conferencing and all those things, that's the broadcast which is happening. So that is relay, okay? So when you use Colossus, you have to write the server in JavaScript. So their framework is in JavaScript. So you have to write that in JavaScript or TypeScript, either ways. It supports multiple game engines and libraries. Primarily JavaScript. I have seen that it supports JavaScript and C#. Okay, Unity you have SDK and JavaScript based things because it's native. They have this many of those libraries which are there. So they have some SDKs. So if you are building a game on it, you can host the server by yourself. Like there are many hosting providers, right? Even Google has Agones and Unity has it, other has it. So your server, PlayFab has it. So you can host the server, and the server can spin up. You have matchmaking services in the game matchmaking service in the game backend. Like PlayFab has a matchmaking server, right? You can do a matchmaking. All that servers are maintained by the PlayFab. So you can use this if you want self-hosting. But if you want a managed cloud kind of thing, they do offer it. That is called Colossus Arena. Okay, so that Arena you can use it. So it's only game backend. There is game server, no game backend. So you have to you have to look at how you can inject that data, which is outside. Like say there is an item, right? That item has some levels, and you have to inject into that game. So you have to look at it. If your gameplay doesn't involve anything from the inventory or something like that, that's okay. You don't have that problem. So what happens if a achievement? So player collected n items. You have to give an achievement, right? Okay. So those things, how you inject and how do you track, all those things are manually, because it's a distinct system. This game server is completely distinct from the game backend. So it can work with any game backend, no problem with it, right? It's an open source project. You can find if you search for it, you can find a project on GitHub. Okay, all the source code is there, and these in the real time. So this is both game backend and a game server. So in the real time, its approach is more towards configuration versus code. Okay, so in programming there are like two things. One is you have to write code. The other is you have to configure that thing. Right? Unity is more configuration kind of thing. Whatever game object you do in the Unity window, right? On the right side in the editor window, that is configured. You are configuring the game object instance with whatever data you are setting in that panel. But you can customize using a script. That's a different story. But primarily game object, there is a configuration thing, right? So in the real time, does prioritize configuration or code. You don't have to write code. Most of it is out of box. You just have to configure it. For building multiplayer servers in this particular platform, they expose it through a no-code UI. So you know Google Blockly. So Google Blockly is a visual programming block language. You can drag and drop things and you can complete that programming task kind of thing, right? So they have no code UI for that. And whatever games backend has the data relating to player, environment, all the things, they can be directly injected into the game server. Okay, it's tightly integrated. So that happens. So it also has some tooling like cassettes or something. So in multiplayer, most of the time, there will be always data sync issues, time sync issues, and the packets will be coming in. Like you have to do logging and you have to look at what was the problem when something is off, something like that, right? So debug all those things. India has a concept called cassettes where they record all the network log which is happening. So you can replay it, you can view it, you can replay it. It's all in, so even without connecting to server, you can replay it on the thing using their SDK. Okay, so it's only cloud only thing, suitable for casual, hyper casual, low physics games. Okay, whenever they are finger soccer, you can build on it, right? If you want to build a say shooting game, not possible. Turn-based game, card games, board games, all those things you can build on it. Mirror. So this mirror has a context. So earlier there was a unit library in Unity. How anyone used unit library in Unity? Yeah, nice. So unit was abandoned somehow by the developers, and these guys took like kind of forked it, or they maintained it. They fixed so many bugs, and it's a whole history which it is written in their server, like their documentation. You can read about the history of Mirror. Okay, so you can build authoritative games and relay games. It's open source plugin. You have you can see all the source code, participate development on Discord, and all those things on the GitHub and Discord. Base code, it was based on Unit, but then they kind of rebuilt everything. Now I think it's completely different product. They have some network viewer where you can see what was the data which was coming in and which was going out, right? So if you pay some premium subscription or something like that, earlier sponsor some one of the contributor, that you will get access to that network viewer. That's what I remember. I don't know if it has changed in like 6 months or something, but that tooling is available there, and it's only Unity only. So if you are trying to build a game which is not Unity, non-Unity kind of thing, Mirror, you can't build it. Okay, so Mirror is primarily Unity based. Because you will write code in Unity, adding the transforms and all those things. So these Mirror, if you want to develop using Mirror, you have to accept the constraint that that game is going to be only on Unity. So somehow you want to build a Facebook build which is light instant game or something like that. All those things are not possible. JavaScript not possible. Okay, so you can host Mirror on PlayFab or anywhere, right? So you can take a headless build, server build, and that server build can be hosted on any of those cloud platforms. Okay, so once that is hosted, it will become authoritative thing. But if you want to use relay, they have lot of transports, like 8 to 10 transports which they have. Out of they have those relay servers. You can host yourself, or you can use one of the out-of-box thing which is coming from the network. Unreal, I think they have one of the relay which supports the Unreal transport. Okay, so Nakama. So this Nakama is a game backend and mostly known for the game backend. It's an open source project, and they have a managed cloud also. So you can use either ways. You can host it yourself. You can in AWS. You can take it from the marketplace. You have to pay that particular pricing thing which if you take from the marketplace, and that's what I remember. So this is primarily game backend, but they also have this game server part where you can code multiplayer servers in Go, TypeScript, and Lua. Okay, so if you want to build a multiplayer thing like multiplayer server, authoritative server, or something like that, you can use their framework, and you can write code on that, and that will become an authoritative server. Okay, and they also have a relay server also. If your game doesn't need anything which is authoritative, you can just use a relay server and sync the data. So both options are available, self-hosting and cloud. Photon. I think everyone in the networking knows Photon. Almost everyone might have used Photon in this room. That's what I am guessing, because if you search for Unity multiplayer, you'll see Photon first, right? So it has been very long, and they are quite popular and quite stable. They have multiple options. So there is a lot of confusion of what Photon offers now currently, okay? Because there was earlier there used to be simply Pun, and then Pun 2 came, okay, then Bolt, okay? But all those things are deprecated. They are no longer the primary products now. They want to push these three things now: fusion, quantum, and real time. Okay. So what is fusion? What is quantum? What is real time? That is a confusion which everyone has. Real time is a networking library. It's a net code. Okay. So it is a low level library. Quantum and fusion are built on real time. They have their own use cases when you have to use quantum, when you have to use fusion. 99% you, like most of the games, they'll use fusion. If you have a deterministic gameplay requirement and those things, you have to use quantum. Okay, that's what the recommendation is. Quite popular. You can't self-host it. It's a managed solution, so you have to download the plugin and you can start building. It's used by many of the games, popular games, very popular. I think every Unity developer who is doing product like code, right, he will always come across one Photon related project. Unity multiplayer. This Unity multiplayer, they are rebuilding all the netcode from scratch from couple of years. I think 2020 they started out. But the good news is now it reached 1.0 milestone. That means you can use in production is what my understanding is. They have some tooling available. They have some network viewers and also netstats which are there. Unity has excellent tooling. Everyone knows it. There is no question of it. You can build a game authoritative gameplay and relay. They have Unity relay which is there. You can sync all that thing without using authoritative thing. You can self-host those builds if you have, or you can use Unity, right? I think that's it from my side. We'll open for Q&A. But before, I want to ask few questions. So how many of you have worked on multiplayer projects? Okay, nice. How many of you are planning to work on multiplayer projects? Okay. So what kind of games have you developed? Like turn-based games, FPS games, or what kind of games have you developed on multiplayer? Anyone can answer. Okay. 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 So we'll open for Q&A. I think we are on time. Yes. I have 10 minutes, or how much time do I have? 5 minutes? Nice. So we are on time. So any questions, Q&A? There's some swag you can take. Abhishek, can you give this swag randomly? So any questions from you?
Yeah, hi bro. My name is Rajesh, and I have some doubt on latencies. Like,
right.
I think the slide is also missed out. I was expecting that.
Latency. Okay, yeah. Latency slide is missed out. So sorry. Okay, sorry for that. So latency means delay, right? So whenever in multiplayer games you have to expect some delay. Okay, so what is the minimum delay you can expect? Okay, what is the minimum delay you can expect? A ping is a minimum delay you can expect. Ping is a round trip. Your packet travels to server and it has to come back. That is the minimum delay you have to expect. If it is 80 milliseconds, 100 milliseconds, 300 milliseconds, 1 second, or whatever it is, it depends on your network. Okay, so that is the minimum delay you have to factor in. But the latency is due to different reasons. Okay, sometimes latency is perceived. Latency is because there are problem with the underlying network conditions. Or your network might be like 150 Mbps bandwidth, everything in a Hyderabad or Bangalore or anything, but your internet provider might be routing packets through the cheapest possible route. So from here to Bangalore, that packet has to reach data center, right? It's not that it will go through only India. It might travel all over the globe and reach Bangalore. It's a complex pricing thing which works out. So what they do is they will route to the cheapest possible route, hops. Okay, it might take n number of hops, but it will reach Bangalore. So that latency will come in. So that is packet routing. QS is like quality of service which you have, like, you know, they are like drops, the network is really not good, various parameters are there. That is thing. This latency is not relevant to many games, like, you know, if it's a turn-based game, right? So in turn-based game, your turn will always, you can expect a 1 second delay, no problem. 2 second delay, no problem, right? If it's a shooting game, right, you shot a bullet and it did not register a hit, but on local one of your thing you have registered a hit, right? So then there will be a problem. You will say that that's not there. So generally ping of 80, 100 for shooting games will be better. Even lesser ping will be better. But it's not possible in India sometimes. Like getting a lesser ping when you're playing with a North American players or European players, that's not possible. So latency is more of it. So game loop also causes the latency. So game loop, sometimes your inherent game loop is blocking, or it has to, this is a different thing, right? So the game loop might cause some even if you in Unity, even if you receive a packet, you can't directly change anything related to UI. It has to be updated only on the main thread. So that packet or data which you receive has to wait till the next frame. So those things are there. This game loop latency won't be a real problem per se. So this frequency of updates, right? So they will be syncing. So it won't be like 30 FPS updates will be there. If your game is playing at 30 FPS, there will never be a 30 FPS update on the network. There will be 10 FPS or something like that. The server data sync might be happening at 10 FPS. Your client netcode might be predicting some of the state, right? So if you are moving, your character is moving in the game. So the netcode might predict that you are going to move straight, and even if it doesn't receive the data till 1 second, 2 seconds, 3 seconds, it might be moving a character straight. Okay, so but then suddenly the data sync happens and you might not have moved, right? You will jump back. So that happens. So whenever you hit someone, that has to go and come back, right? So those things will be there. Most of the shooting games, that is like your hit has to be registered and that will be sent to the server. Then server validates the data of the state. So 5 seconds ago, 1 second ago, what was the state? Were those two players in the same place proximately? Is that possible, really possible? Most of it will be approximation. So it won't be like server side thing, right? I registered I'll shoot, that bullet will hit that guy. So that sync doesn't happen real time. That always be your local decision will be validated by server on a state which was previously noted. So x milliseconds ago, like every so state is always versioned in the server. So that state will have a number or a version kind of thing. So that at that time it will check with whatever you are saying, that okay, I hit X player. So it will validate or invalidate that particular. So that is about latency. So there is like client prediction. Client prediction is one thing which you can read about. So so if you really have you read this, come across, I don't know if you can see it, Gabriel Gambetta. That's what you can search for it. So there are a series of articles which are really good, which give you an intro about what actually multiplayer game development is about, concepts wise. Okay, you can look at it. There is a series of tutorials which are there. You can see like on top right, client server architecture, client server prediction, entity interpolation, lag compensation. The lag compensation comes from the latency and all those things, right? So this is one resource which I can leave you with. Then there is this Gaffer on games. Gaffer on games is very popular with the netcode guys who are starting out, at least on netcode. Okay, so these are conceptual things. This won't help you like what happens in Photon or Unity library, but you will understand why that is happening. why that might be happening. Okay, so this, this is one really good website, Gaffer on Games. Like you have to read if you are starting out on netcode. Okay, so any other questions? I think time is running out. Done. So yeah.
So the tools that you showed, those are those tools very scalable? So let's say at a scale you need a lot of custom code, lot of custom databases that you need, right?
Pardon me. Which tool
So
are we talking
the
about?
tools that you showed, like those are
Tools in the sense the frameworks which are
yeah,
discussed,
the frameworks
like Unity multiplayer and
yes,
those things.
yes,
Right?
yes. So let's say you have a front end and you just integrated some tool for the backend logic and all, right? Game state synchronization and all. But let's say you need a lot of custom code and a lot of databases, data stores that you need the data to sync in. So how scalable are those tools?
So whatever tools, whatever game frameworks which I have talked about, Photon, Unity multiplayer, all those things are production grade. They are working. Many games are making millions of dollars on those tools. At least most of the tools. Okay, so they are stable. Okay, one thing. And we can take this discussion offline. You can visit our booth in esports arena in the back.
Okay.
Okay, Indie real time. There is a booth. So I'll be there. I'm not promoting it, but we can take this discussion for the time sake. Okay.
Hello. I just wanted to ask, so there are techniques to like counter the technical cheating, right? So are there any defined ways to counter the behavioral cheating?
Sorry, I could not get your question.
So there are ways to counter technical cheating, right?
So technical cheating. So some games you can't really realize that cheating is happening. But using a machine learning or most of the data which can be logged on the server side, right? You can realize that okay, this set of people are cheating because they are in the same game most of the time, or they are winning, or they are always whenever kill happens or something like that, right? Or so those things can be done. Cheating can always be caught. But it's a business decision. Like, do you really want to spend resources on finding out cheating? Then what you have to do? You have to ban them, right? So those things. Cheating real time it's not possible sometimes in few games that you can catch it real time, but cheating always leaves a trail. You can always catch them anytime. So most of the multiplayer games you see, right? So every week, someday they will ban so many thousands of hundreds of players. Your account might be because of the machine learning algorithm which they are using, but it's always retrospectively they look at the data and they will ban it. Okay.
So sir, my
last two questions. Sorry, I think yeah.
My question is sometimes like oftentimes we see there is client side lag. So oftentimes we also see there is server side lag. So how do we optimize servers?
So server side lag, if there is server side lag, I think that's a much deeper problem which you have to look at whether you are really using the right technology, right? So so that part I can say, but optimizing servers is a whole big topic and it can't be answered in a single like there is no thumb rule like okay you do this the server will be optimized. Right?
Hello.
Yeah.
I have a very basic question. Which multiple server supports with Unreal Engine? Because we are planning to our game publish on multiplayer.
So that
for Android.
So I have worked on Unity a lot, okay, and JavaScript and Unity. So I don't really know what it is, but I am pretty sure like there is a transport which Unreal has, relay transport which they have, okay.
Okay.
But I can get back to you. If you leave then you can take my card and I'll get back to you. Sure.
Okay.
You can
Thank
ping
you.
me and I'll.
Thank you very much.
Thank
Very
you.
nice session.
So my question is, back in days, there used to be a game called Ragnarok MMORPG game.
Okay.
So at that time, they achieved a multiplayer game with like 14 kbps or 12 kbps of internet. Got it? So when compared to that, and now we are totally advanced. So how can we achieve with such a kind of?
So your people come like people have this thing like should I optimize network? Should my game will be? Should I expect like so size of the game, size of the binary and the amount of data it syncs, right? These are always trade-off, right? So over the time, the network capacity is increasing, server capacity is processing is increasing. Like there is a joke like, earlier they used the computing power to launch people onto humans. We are launching Angry Birds on in our phone, right? Same computing power. That's a joke, like last decade joke. I don't know if it's relevant, but that will always be there. But for every kind of game, there is always an audience, right? Arcade games, there is audience. Those things will be there. So if I were to build a game, multiplayer game, my priority would be how fast I'll build and how fast I can take it to market and test out whether the game works or not. Okay.
So you suggested to make an initial thing and launch it and again test again. Then after getting the feedback, build the whole game.
I will suggest stick to because this networking, multiplayers, and all those things is a very huge topic involving multiple things. Okay, domains, the game. So I suggest to stick to one of the solution which is already built by knowledgeable people. Okay, and use it unless you have like $1 million funding and you can hire lot of net code engineers and you want to optimize it, right? Still, like expectation from players might be like your data is very, like your gameplay doesn't involve that rich things and all those things. You might have to increase it. So that's the thing. Optimization, over optimization might not be solution for it. I think we'll stop this thing because these guys have been cooperating. Thank you everyone. But I'll tell you, you can drop by our booth and sorry. I'll just 1 second. I'll share my phone number. I think you can reach out to me on. Patient, yeah, I think. Because can you put on 1 second? Yeah, you can reach me on this phone number, WhatsApp or something like that. I might not respond immediately, but I'll get back to you in a reasonable period of time. We can continue this discussion. You have any questions, anything. You can also come back to our booth and you can mail me. You can always mail me. I have shared my email. Okay. Nice talking to you. Nice meeting every one of you.